Hi, good day to all. You all are welcome to the video on mechanical measurements and metrology. Myself, Ajith Joshi, STEM professor from Canada Engineering College, Bandwada. Well, today we are going to discuss regarding the mechanical measurements and metrology of Module 1 from the introduction part. This is the syllabus of mechanical measurements and metrology as per VTU 18ME36B. Course objectives are understanding the concepts of standards of measurements, principles of operation and calibration of an instrument, understanding the various methodology for measuring different dimensions and concepts of limits, fits and tolerances, understanding the various sensors, transducers and the applications. This subject also helps to understand the different devices to measure force, torque, pressure, flow, etc. Understand the different devices used to measure. The module 1, it is about the introduction to metrological concepts, calibration, line standards and end standards, different types of standards which is used. Along with that, the line different second part of this module 1, it is related to the linear measurement and angular measurements. Module 2, it is related to the systems of there you are going to learn system of weights, limits, tolerances and gauging, comparators, functional requirements, different types of comparators, mechanical, electrical, optical comparators. Module 3, it is about the measuring methods of screw thread and gear. The second part of this module 3, it is totally related to the gear tooth measurements. Module 4, it is about the measurement systems and basic concepts of measurement methods, generalized measurement system and different terminologies which is used in measuring techniques or measurement system. The transducers you are going to learn, we are going to discuss in the module 4 about the electronics and electrical transducers and other things. Also we are going to discuss about the intermediate modifying devices and terminating devices, especially the CRO and oscillograph working principle in the module. Module 5, it is related to the applied mechanical measurements, that is nothing but measurement of force, torque, pressure, dynamometers, different types of dynamometers. Along with that, the types of pressure measuring instruments, elastic members, Bridgman gauges, McLeod gauges, Pirani gauge, etc. Also, the second part of the module 5, it is about related which encompasses the types of strain gauges, electrical strain gauge factor and the temperature compensation and different preparation mounting of strain gauges, methods of strain measurements, temperature compensations, resistance thermometers, thermocouple and the law parameters. These all things are discussed in the module 5. So at the end of this course, the students will be able to define and explain the fundamental concepts of metrology and use of various standards. Students will also be able to demonstrate system of limits, fits, tolerance gauges and interchangeability. Students will be able to illustrate the working principles of various comparators and measuring devices for physical quantities such as angle, gear and screw thread parameters. Students will also gain knowledge to define and explain the measuring methods and generalized measurement systems as well as working of components. Students will also be able to demonstrate the working of force, torque, pressure, temperature and strain. So some of the good textbooks which is you can refer for this subject is Mechanical Measurements by Beckwith, Engineering Metrology by Arkajan, Engineering Metrology and Measurements by Bentley, Theory and Design for Mechanical Measurements, Richard Figliola, Donald Besley, and Engineering Metrology by I.C. Gupta. Dioblin's Measurement System by Ernest Dioblin. These are some of the textbooks and references for this. Coming to the module 1, Introduction to Metrology. As I mentioned already, this subject is totally related to the metrological concepts and measurement systems. Why metrology? Metrology is required to understand the basic concepts of any kind of physical quantity which we are going to quantify it. And why this quantification? If I want to ask anything, we need to quantify it in terms of numbers followed by units which is meant for that physical quantity. Example, if it is a length I want to travel. I am saying that from this place to place A to place B, this is the this is the length, or this is the distance. Let me say around 10 kilometers, 5 kilometers, or something like that. So what is that 5 kilometers is? For what length we are calling it as a 5 kilometers? Yeah, or if I am going for a cloth, a shop asking for a cloth, what is that length which is going to be the 1 meter or half meter? So to specify that length for 1 meter, we are going to quantify it. This is the length for which we can call it as a 1 meter. That is kept as a standard. In the same way for a mass also, if I am saying any physical object which is weighing this much, let me say 1 kg or 2 kgs, so what is the amount of mass which I can call it as a 1 kg? For that, the metrological concept is required. At the same time, we need to define it. We need to say that this is only the physical quantity. For that, I can call it as a 1 kg. If I can call this as equal to 1 meter, then I need to specify that length. For that, the metrological concepts are required. And for measuring it, for saying that this is the length for which I can call it as a 1 meter, that is what the concept of measurement, the science behind this pure measurement itself. Metrology. So now we will define what is metrology. Metrology, as I mentioned already, it is a science of pure measurements. It includes all theoretical and practical aspects of measurements. A quantity measured is always incomplete without any units. A man without a name. So always, if I want to call some human being, let me say myself, Ajith. When I'm saying that myself as Ajith, this body is called as Ajith because I have been named as Ajith. So similarly, any human being, if I am going to call him with some specified name, in the same way, if any kind of quantity, if I am saying that this is a object with, or any kind of physical quantity with some specified by units, then it clearly indicates that which kind of physical quantity it is meant for. If it is a length, I am saying that this is in terms of meters. So obviously I am going to indicate that it is in terms of meter, mean to say it is a length. If I am saying it is in terms of Newton, it is in terms of kg, then I can say that this is either a force or a weight or something like that. Similarly, for all any kind of objects, I need to specify in terms of a units. If I am saying that this is a bar mean to say always it is meant for pressure. So all kind of physical quantities or any kind of physical object, or we need to specify it with the units. So for that, we use a basic law of physics. Then coming to the measurement is always plays a very vital role in the R&D, because whenever I am taking any kind of object or a physical quantity or something like that, or any kind of aspects, and I'm going to quantify it. When I'm quantifying it, I am specifying it or denoting it with the help of a number followed by some units. When I am able to quantify it, then it is very easy for us to analyze it. For that, the measurement concepts are required. And for everyday progress, whether it is a domestic application to the industrial application or scientific research application, we need to quantify it. We need to say that this is the quantified value, and for that I can say this is an equivalent values. For that, a measurement is required. It is always like measurement is always like a science of measurement. Metrology is always like a science of measurements associated with correctness, evaluation of the uncertainty of measurement, and also validation of results by specifying its limitation. So what is metrology is concerned about? It is all concerned about the establishing the units of measurements. Establishing the units of measurement mean to say, example, as already mentioned, if it is a mass or an object, it is weighing 1 kg, then I am saying that for this much mass, for only for particular mass, this is 1 kg, yeah, or 100 grams. Yeah, when the object is weighed, or it is equivalent to this mass, then I can call this as a 1 kg. Or when I am saying this is a length, like example 1 meter length, for this much length I can call it as a 1 meter, then that need to be established. So for establishing of measurement, we need to understand the concept of metrology. And at the same time, when I am saying that this is equivalent to 1 meter and I am saying it as a one standard, so I should be able to reproduce those standards. So different types of standards which we which we are going to discuss it in further classes. That is about reproducing the one particular standard, that is very important, because one unit or one particular standard we cannot use it everywhere, so we need to reproduce it. For that metrological concepts is required. And at the same time, when I'm saying there are a number of types of standards, when I'm reproducing it, it should not lose its uniformity. That is very important. Example, if I'm saying that I have 1 meter, I am going to measure it at the part, like let me say a very cold temperature area like Himalaya, where I can measure the temperature, 1 meter bar, which is whose length is equal to 1 meter. The same 1 meter with need to be equal, like when I'm taking it to the Karnataka, like a Bangalore, I need to measure the same 1 meter itself. So for that, uniformity of measure need to be ensured. That is possible with the help of metrology. Next is about developing the methods of measurement. For measuring the length, let me say a ruler is used to measure this is equal to 10 centimeter. When I take it with the help of a vernier calipers, it also need to measure the same 10 mm. So there are different methods by which we are measuring the length, or different instruments through which we are measuring the length, with the help of a light or with the help of some other standards we are measuring the length. So that is nothing but we are developing different methods that is possible when we understand the metrology concepts. And the metrology concept is always again concerned about analyzing the accuracy of methods of measurement. Maybe 100 methods are developed, we need to analyze what is the accuracy of that method, what is the accuracy level that method can yield. And next is about establishing the uncertainty of measurements. Uncertainty of any kind of measurements, uncertainty need to be established. We need to understand it and we need to bring it to the certainty. I mean to say, we need to minimize the possible errors. We need to we need to look such a way that the measurement method give proper readings every time when it is measured. Developing methods of identifying for different possible errors in that instrument, and also we need to eliminate. That is very important for any kind of measuring instruments. Next is about objectives. A thorough evaluation. What is the major objectives of metrology? Example, the thorough evaluation of newly developed products to ensure they satisfy measuring capabilities. Measuring instruments always possess some capabilities. Let me say a 0.001 mm LC micrometer. It is able to measure the length with the last decimal, which is equal to third decimal. So if I am going for a micrometer which is a 0.01 mm, then obviously it is about second decimal. So each measuring instrument has got its own capability, and that need to satisfy, that need to be ensured, and it need to satisfy the measurement capabilities. Always it is about the process capability. When I am saying a process is involved in a whole manufacturing process, okay, about a process is involved which is related to the measurement concept or metrology concept, that need to be always better than the component tolerance. Example, let me say a shaft is being manufactured with 10.006 plus or minus of 0.06 mm. The process need to be established such a way that it should be better than that. Mean to say, example, it should be able to measure up to the third decimal, or having a better measuring capability. If we let me say, if it is able to measure with the second decimal, then there is every possibility that the tolerance value may not be accurate. So that always it is expected that component tolerance value, process capability, it should be better than the component tolerance value. If Third point, it is about the capabilities of measuring instrument. It need to be adequate. As I mentioned already, if it is 10.06, then the process capability with encompassing the measuring instrument, which is always having a better adequacy or better measuring capability for that process. Always it is this whole metrological concepts is meant to minimize the cost of inspection, cost of rejection, and again the cost of rework. Always standardizing the measuring methods is very important. Maintenance of accuracies of all measuring instruments is another important objective of this technology. we'll discuss about the different types of terminologies which we generally use in the metrology and measurement. First is about calibration. Calibration, it is always about comparing the known standard with the unknown standard. Mean to say, I already said a meter for this much length, a 1 meter what we are calling, and it is a one particular standard. It is kept in some lab, okay, and it is being reproduced. The same standard, we cannot bring it to our domestic application. So it is being reproduced, and one particular length we are calling it as a 1 meter. So that newly produced scale need to be compared with the standard scale, and that need to be ensured that the newly developed scale is always are equivalent to the standard scale. That process of comparing the known standard with the newly developed standard, or pre-established arbitrary scale with the newly developed standards, that is the process, or that process we call it as a calibration. Next is repeatability. A scale I am using, let me assume that a scale I am using, it is giving 1.01 meter once, 1.02 meter second time, 1.009 the third time. So it means to say every time when I am going to read the length with the help of that scale, it is giving a very precise reading which is nearly equivalent to each other, very close with respect to each other. And the capability of an instrument to reproduce the same value, mean to say every time I am getting a different reading. As I mentioned, three readings, three different readings. Repeatability of an instrument is about, it is the capability of an instrument to produce always 10.01 itself. When I am saying let me say the first time to the fifth time, it should be able to reproduce the same value. That is that capability of an instrument, we call it as a repeatability. Error. Error is always the difference between the measured value and the true value. The actual length, let me assume it as a 10 mm. When I am measuring the same 10 mm with the help of a vernier calipers, it is giving 10.01 mm or 10.001 mm. Actual value is 10 mm. So the difference is now is 0.001. So that is nothing but the difference value is nothing but a error. So always it is expected to have the lesser error. I mean to say it yields a better accuracy. Accuracy, then when I am saying about the accuracy, what is this accuracy? Accuracy is about the correctness or the agreement of a result of a measured value with the true value. As I mentioned already, the 10 mm and the 10.001 mm. So how much accurate it is? It is about 0.001 mm accurate value. So mean to say, of whatever the reading which is yielded by the measuring instrument, how close it is equivalent, how close it is to the true value, that is what the accuracy is. When I measure the same reading for n number of times, it should give almost equivalent to the 10 mm, that which is a true value. That is what the accuracy is. Next, about the precision, I said 10.01, 10.002, 10.0009. Okay, so it is giving almost 10.01, 10.02, 10.0009, which is very near. Each value is very near to with respect to each other. So that means to say that is a precision. If I am going to say, let me say at the fourth time, if I am getting the value which is equal to 10.05, then it is very far compared to the 10.01. So it is not a precise. Precise always it is about the when I am say taking n number of readings, each value should be very close with respect to each other. So that ability of an instrument to reproduce the closer values every time when I measure, it is called about a precise instrument. Accuracy means those values need to be equivalent or near to the close value, that is a true value, that is accuracy. So accuracy and precision need not be the same. Like example, if I'm taking this as a figure, let me say this is a like a precise values, because the first value, the second value, and the third value and fourth value, these four values are very close with respect to each other, whereas whereas this is a true value. When I am comparing this true value with the obtained values, they are far with respect to each other. So mean to say these all values are highly precise, but since they are far from the true value, they have low accurate values. So whereas here when I am coming for this, I can see though four different values are scattered with respect to the true value, they are very close. Four values are scattered over the range of a measuring scale or a zone, but at the same time the first value is far from the second value, and second value is far from the third value is far from the fourth value, and fourth value is far from the first value. So mean to say these are all highly accurate because it is compared to this that is a true value zone. These four values are very close proxy, but at the same time they are far with respect to each other, they are far. That's why these are all four values are low precise but highly accurate reading. So that is about the precision and accuracy. Coming to the measurements, there are different types of measurement standards. Let me say first I am going for the linear measurement. Let me consider the linear measurements. There are two standard measurements for linear measurements. One is a metric standard, and that is meter and yard. English standard always it is about a yard, and a metric standard we follow the meter. Due to the advantages of metric system, most of the countries are adopting metric standards with meter as a fundamental unit of linear measurement. Length, it can be measured by either a line standard, n standard, or wavelength standard. So what is line standard? According to this, a standard yard or a meter is defined as the distance between the two scribed lines on a bar of a metal under certain conditions of temperature and support. What are the characteristics then? A scale can be accurately engraved. A steel rule we are using for measuring for domestic applications. There are a number of lines which are engraved over the scale. So the distance between any two line that gives the length for particular measurement. So a steel rule with about plus or minus of 0.02 mm of true dimension. A scale is quick and it is very easy to use over a wide range of measurements. The scale markings are not subjected to wear, although significant wear on leading end results in undersizing. The scale markings, they are not subjected to wear, but at the same time the significant wear on leading end results in undersizing. That is example, the beginning of the scale, if it is going to worn out, then obviously it is going to cause the undersizing error. Next about the next characteristics is about parallax effect, because each line need to be drawn parallel with respect to each other. So parallax effect is inherent in this kind of scales, and it is a source for both positive and negative reading errors that is possible. Scales are convenient always with given tolerance and length measurements, and when it is conjunction with microscope. Yard, how do we define the yard? Yard is always defined as a imperial standard. It is a imperial standard yard. It is a bronze bar of 1 inch square cross section and 38 inches length, and two round asses 1 inch away from two ends up to center plane of the bar. A gold plug of 0.1 inch diameter having three lines engraved transversely and two lines longitudinally is inserted into this hole so that the lines are in neutral plane, and this standard hole setup is kept at a 30 to 62 degree Fahrenheit and center lines of the plug at a 62 degree. The purpose of keeping the gold plug lines in neutral axis is due to the bending of beam. The neutral axis and always unaffected. So this is how we can understand. Let me say this is the gold plug which is engraved with three parallel lines we can see here, and two longitudinal lines here, and this center line is taken as a reference. The similar kind of engraved gold plug is inserted and at the other junction. This bronze bar, which is made up of 82% copper and 13% tin, 5% zinc. The length between this center line from this point to the center line of the another gold plug which is kept opposite. This distance should be equivalent to 36 inches. So 36 inches is equal to 1 yard, and on either sides we can see from the center line to this end of this bar, this distance is equivalent to 1 inch. So 1 inch on either side, the similar distance or length is kept. So the cross section of this bronze bar is a square with one cross section, and it is supported at a length of 0.57 L with respect to the center axis. So why it is based on the area point support. What the area says, the condition is when the distance between the supports is the condition to obtain a neutral axis, or like it should be a maintained and constant flat surface. The condition obtained when the distance between the supports is 1 divided by root of n square minus 1 into capital L, where n is the number of supports. Here in this case there are two supports, length of the bar which is equal to 30, and is for a simply supported beam it is 1 divided by root of 3 into capital L, which is equal to 0.577 L. These points of support are known as area points, and in other words the distance of each support from the center of the bar is 1 minus 0.577 L divided. So that is about the yard. Similarly coming to the prototype meter, this is the distance between the center points, center portions of the two line. Here it is made up of a pure platinum alloy plus platinum plus iridium alloy, which is inoxidizable. The bar is kept at 0 degrees Celsius under normal atmospheric pressure. It is supported with the help of two rollers at least 1 centimeter diameter, symmetrically situated in same horizontal plane at a distance of 751, so as to give minimum deflection. It is again 751 is calculated based on the area point. It has a shape of hinged cross section, have a web whose surface lines are on the neutral axis. The shape gives maximum rigidity. The web shape gives a maximum rigidity to the whole standard, that is a meter bar. The overall width and depth are 16 mm each. The standard is kept in a BIPM in Paris BIPM lab in the Paris. The yard discussed was found to be decreasing compared with the meter line standard. The reason being the yard more susceptible to changes over time because it is maintained at 62 degree Fahrenheit. The meter line standard was more stable due to platinum iridium alloy, and 1 yard is equal to 0.9143981 meters. It is being derived, and as longer by 4 parts in 1 million, international standard was adopted as 0.94144 mm. It is standardized. So this is a meter bar. Here we can see so this is about the prototype meter. Here we can see there is a one engraved line here and another engraved line opposite to it. Both are parallel with respect to each other, and two perpendicular engraved lines we can see here. If there is any changes or deviation with respect to this engraved line, then that can be identified easily. That's why these parallel perpendicular lines are drawn. The whole meter bar is maintained as a web cross section, and a neutral axis is drawn so that we can understand if there is any deviation, and stability is maintained. Now coming to the distance from the distance between these two parallel lines, it is equal to the 1 meter, which is equal to 100 centimeter or 1000 mm, and total length of this web is 102 centimeter. And this whole web is our standard meter bar is maintained at 0 degrees Celsius, as I mentioned, and composition of that is the 90% platinum and 10% iridium. So this is about the linear measurements. Thank you. I have used many sources from the net as well as from the textbook, and I acknowledge all the textbooks and textbook sources as well as the internet sources which I used in this PPT. Thank you for I am not saying that this it is a disclaimer in that we are used many teaching materials for this PPT. Thank you for from the sources as well as to all for the patient listening. Thank you.